Today we're going to take a look at the exact trig values when it is not on the unit circle. Remember, when we're talking about the unit circle, we have a circle that has a radius of 1, and then we measure the size based on that. So on this one, we are not going to be on the unit circle. We're going to have triangles of all sizes and different quadrants as well. So as we look at this one, you can see we've got a first quadrant triangle, and we're asked for the sine of this angle. Now, from time to time, you will get one that does fall on the unit circle, and when it falls on the unit circle, be thankful and just take that number. But we clearly don't have one here. We're not familiar with these values. So as we look at this, we've got to remember our old trig ratios, whether that's SOHCAHTOA, some old hippie, whichever one you were taught, we need to know these things. So when I say sine, that is the trig ratio of opposite over hypotenuse. So as we draw this, and you don't have to draw the triangle on these, I generally do. I'm not really good with memorizing which is which, but we're looking at this triangle right here. We don't know what the hypotenuse of this triangle is. We do know the x value. Well, x value is left to right movement. That is 17, square root of 17. And we know the y value is 8, so it's a triangle that has a height of 8. So if we were to move this triangle over to the side, this is what we're looking at. A right triangle with a side of the square root of 17 and a side of 8 and a hypotenuse which we do not know. So we can do Pythagorean's theorem to find out what our hypotenuse is, because we do have half of our answer already. Because remember, sine is opposite over hypotenuse. Well, we know the opposite side is 8 here. So we just need to find the hypotenuse, which is what we're looking for right here. So 8 squared is 64. 17, square root of 17, squared is 17 equals the hypotenuse squared. So we have 64 plus 17, which is 81, equals the hypotenuse squared. So we take the square root of both sides, and the square root of 81 is 9. So we learned that the hypotenuse of this triangle is 9. So now we have all of our information needed to find the sine. So the sine of the angle is 8 over 9. So let's take a look at this cosine. Remember again, cosine is opposite, or adjacent, over hypotenuse. And if we were to construct our triangle here, we have an x value of -3 and a y value of the square root of -7. So if we're looking at this angle, and this is where you can use those relationships we talked about, where cosine is the x value and sine is the y value. This is basically what we were talking about here. So we have the cosine of our angle. I'm going to write it out this time. Cosine of our angle, which I'm labeling now, is the adjacent side, which is -3, over the hypotenuse, which we don't quite know yet. But we do have a triangle, so we have a triangle with 2 of the 3 sides, and it is a right triangle, so we can use Pythagorean's theorem to find the missing one. Now I'm going to change the -3 to a 3. I'm going to change the square root of 7 into 7. This tangent, this hypotenuse, is actually going to be positive when we look at these sides, because it's a length, it's not an ordered pair like the other two. So we're going to take this to Pythagorean's theorem. 3 squared plus the square root of 7 squared equals our hypotenuse squared. 3 squared is 9. Square root of 7 squared is 7, equals the hypotenuse squared. 9 plus 7 is 16. And remember, this is the hypotenuse squared, so we need to square root both sides. And we learned that our hypotenuse is equal to 8. And as you can see, when we had this at the top, that's the only part that we were missing. So the cosine of our angle theta is equal to -3 over 8. And we keep that negative sign because the x was negative. But just remember, the hypotenuse is not a negative value. And you also want to think as well, when are the cosines negative and when are they positive? We're in the third quadrant, so cosines are always negative when they're in the third quadrant. Sines are negative in the third quadrant, but tangents are positive. So here we have one that does not have the diagram. We really don't need the diagram, but if you want to draw it, you can. Remember, cosine, of course, is adjacent over the hypotenuse. Well, the adjacent side on cosine is always the x value. Regardless of where it is, it's always going to be this value. So we already know half of this information. And if you're wondering, well, are we always looking for the hypotenuse? Basically, yes. We can create questions where we have the hypotenuse and we're going to be looking for the other parts. But if you think about it, it's a coordinate. So it's not very often you know how to get there. You normally just know where it is. So here we go. We have to do Pythagorean's theorem. And again, you can, I'm going to do -8 just to show you. If you do put in negative signs, it's very important that you put them in parentheses because remember, when you square a negative, it turns it positive. So -8 squared is 64, so you see it takes care of itself. And by the way, we are in the second quadrant here, and we're looking for cosine. Cosine in the second quadrant is always negative. So we got another familiar number here, 81 equals the hypotenuse squared. So the square root of 81 is still 9. So the hypotenuse would have a measure of 9. The hypotenuse would go down here. Now we haven't had to reduce yet, but we would reduce if given questions that have fractions that reduce. If we wanted to find out what this angle was, which might do later on, remember we just need to do the inverse cosine. Inverse cos, and then we would do it on the other side. So the angle, if you're interested, would be the inverse cos of -8 over 9. But we're only looking for the ratio right now. Right, we've got two more examples we're going to take a look at here. This one is a sine. We are in the second quadrant because our x is negative and our y is positive, and sines in the second quadrant are positive. So make sure when you're done with this, you have a positive answer. So let's take a look. Again, we need the hypotenuse. We can already set up half of this already. Remember, sine is the y value, which in this case is 2 square root of 3, over the hypotenuse whenever we finally come to the hypotenuse. Because remember, it's opposite over hypotenuse. If you're having a hard time seeing it, actually draw the figure. This is going to be back to and up to square root of 3. This is the angle. The angle of interest is always the one that's touching the origin, by the way. And it's one of its sides should always be the x-axis. Don't ever use the y-axis to create a side. All right, so we need the hypotenuse. That's our common theme for today. And that's what it will be all day, by the way. You have to find the hypotenuse throughout. So take a look at what I did there. It's very important that you put both of these terms in parentheses, because not only the square root of 3 is getting squared, but the 2 is as well. A lot of times we overlook this 2. And then also the negative number has to be in parentheses, because a 4 should be coming out of this, not a negative 4. If you ever have a negative number come out of that, then you better look it over, because it can't happen. So the part that's getting squared here is the 2 and the square root of 3. Well, when the square root of 3 gets squared, we get the value of 3. So I'm going to highlight these to show you what became what. The 2 squared became 4, and the square root of 3 squared became just a 3. And then notice it is in parentheses because we were multiplying those two terms. So we're at 4 plus 12 equals h squared. 4 plus 12, of course, is 16. And the square root of 16 is 4. So our hypotenuse is 4. So we're going to take this to our equation. I'm going to erase this portion here. So here's our equation. See if anybody catches what's going to actually happen here. Sine of theta equals 2 square root of 3 over 4. That is not an incorrect answer, but it is not the best answer. Can we see what's supposed to happen there? Hopefully you recognize that 2 and 4 reduce. So sine, and you guys have an advantage today because I did give you multiple choice on your homework assignment. So you'll be able to tell if it was reduced, but that's what that would look like. So that also means something else to us. If you go back and look at your unit circle, we're dealing with sine in the second quadrant that is equal to the square root of 3 over 2. We can go back at our unit circle and see what angle degree measure of the angle is just by looking at our unit circle. All right, the last example. If you're wondering why we've been putting off sine, our tangent, excuse me, a lot of times we put off tangent because we want to save the harder ones for last. That is not the case today. Tangent is much easier than either of the other two, because if you think about it, tangent, the trig ratio for tangent is opposite over adjacent. It does not require the hypotenuse. Well, here's another thing we told you as well. Tangent, if you look back at your unit circle, is the y value divided by the x value. So we have an x value of -3, we have a y value of 5, that's the second quadrant. So if you go back and look at your notes, the tangents in the second quadrant are negative. So make sure you have a negative value here. But here's what we're going to do. We're going to take this trig ratio, y over x. So tangent of our angle is equal to the y value, 5, over the x value, square root of -11. This is where I'm hoping you guys have all adopted my bump and keep method. So I'm going to bump the square root of 11 up to the top, and I'm going to keep the radicand as 11. This negative sign cannot just disappear, so what I'm going to do is I'm going to put it right there in the front. It could have stayed in the bottom, but I prefer not to keep it in the bottom there. I like the way it looks in the front. You're not going to see multiple choice answers where the negative sign is in the bottom. So might as well practice doing it the way you're going to see it. So there is our tangent value. When you get tangent, you were kind of given a gift on these, so don't overthink these. Remember, it is y over x, almost like the slope, change in y over change in x, but this is not really change, it's just, it is what it is. All right, you guys have about 10 question examples posted on Kami. Good luck.